Ready. Welcome everyone to the July 19th Connectivity Working Group call. Excited to have you all here. We have Justin Hill presenting from Southern Company on some awesome demand response work that he and his colleagues have done. That'll be great. Then I'm going to talk about this more later, but I'm going to try and make things a little more interactive than usual today. So we're going to save a little bit of time at the end just for some open discussion questions that I've thought about in advance, but folks are also welcome to shoot me some ideas for future discussion topics just so we can have more of an open floor and have people who aren't presenting also share their knowledge and insights. Daniel, can I get you to read the antitrust compliance statement?
Sure. Antitrust compliance statement. The Advanced Water Heating Initiative is a member-supported collaborative of professionals from across the U.S. This diverse membership includes numerous competitors, and care must be taken to scrupulously abide by federal and state antitrust laws. Members should remember that antitrust compliance is important at all times. At this and other AWHI meetings, participants should not discuss competitive pricing, profitability, allocating markets to their customers, or promotion of a particular product or accessory.
Thank you very
Well done,
much.
Daniel. That's the victim process of being new to the call. You get baptized that way. So.
Exactly. All right, Jeff, I'll turn over to you for some updates.
Yeah, thank you. So we're excited to hear from Justin and what they're doing down there at the Southern Company, and I would also like to encourage everybody to lean into this. If you've got questions that are appropriate that need clarification on a particular slide, let's put those in the chat and I'll keep an eye on that. If it can wait till later, that's fine too, but we'll try to manage that, and we will have lots of time at the end. On I'm going to pivot topics. It was not advertised in the meeting agenda. We are just in the process, literally either today or Monday, releasing the new Advanced Water Heating Spec 8.1. And there has been conversation and notification about this for the last 18 to 24 months. We are now going to be enforcing. You either need to be certified with an EcoPort certification on the OpenADR EcoPort listing or AHRI 1430 listing. I've not seen that listing, so for those of you who are waiting for AHRI, I might suggest you get your EcoPort certification. And after September, we will be not listing companies on the NEA's Advanced Water Heating Qualified Products list unless you have that certification either through EcoPort or AHRI 1430. So if you've got questions about that, don't hesitate to call me or write me a note. But you have about 60 days to get that up and running. We've been talking about this for more than 24 months. So turn it back to Noah.
Thank you so much, Jeff. So just a brief call agenda. We're already kind of doing our welcomes. As I said before, Justin will be presenting on demand response and Southern Company's journey through that from a bunch of different pilots, I believe. And then, we'll have some discussion topics. Just everybody's feel free during that time to kind of pop in, either hand raise or just unmute themselves and jump in when we do that. And it'll just basically be a clarifying question with, it's kind of open-ended related to heat pump water heater demand response that, I thought of. But again, in the future, if you want to have your own question ideas, and that would be excellent. So real quick here, new participants in AWHI, please come off camera, introduce yourself, tell us who you are, where you work, etc.
So we're going to call out Daniel because he's new.
Sure, I'm happy to go. Yeah, no worries. I'm Daniel Caldwell. I am the new business operations manager at Site Skycentrics. So I've been working with Tristan these past couple of weeks. Just kind of excited to learn more.
Thanks, Daniel. Anybody else?
Next.
Awesome.
Yeah, this is Mitch Dro with Puget Sound Energy. I'm the new residential demand response program manager. So excited to join the group here and learn and participate.
Good to have you here.
I can go next. Hi, everyone. My name is Amélie Besson. I'm a program manager with AEA, Association for Energy Affordability, and I manage a load shifting program.
Thanks, Amelie. Good to have you here. Amelie does some awesome work.
Thank you, Noah.
Wonderful.
Hi, I'm Kevin Smith with Bradford White, working with Julian on our IoT and connectivity products.
Sweet. Thanks, Kevin. All right. So let's get into some AWHI updates. So first thing that we're trying to mention these days is that AWHI now does have a YouTube channel, so we no longer need to send out stream links. Everything's just on YouTube for convenience, and even if you're not part of other working groups, you're able to see all the most recent videos for residential, for multifamily, all that, in addition to the videos from our own connectivity working group. Also, very importantly, mark your calendars for our all-day Heat Pump Water Heater Day event on October 23rd. My colleagues and I have been doing some fun prep work, getting a lot of awesome presenters and speakers and panelists for this day. So it'll be a whole day of Heat Pump Water Heater themed events. And my colleague Joe Wachunas, as usual, will be in his trademark Heat Pump Water Heater costume, which I hear has been revitalized this year to be an even better costume. So definitely exciting. Mark your calendars. And thanks to our sponsors. With that, I'm going to let Justin take the floor. And again, Justin, if you just want to tell me next for each slide, I'll move things along.
Sounds good. Thank you, Noah. So let's see. I guess I'm here to talk about Southern Company's journey through water heating demand response, specifically heat pump water heaters. And I guess Southern Company's journey on this is really around my journey through R&D of looking at heat pump water heaters and how they become a grid resource and grid interactivity and all the things that lead up to the demonstrations that I'll talk about here today. And then I'll talk about some of the issues, some of the positives, and then maybe try to leave you with some next steps. So if you can go ahead and go to the next slide. And I also apologize. I'm in an awkward setup here. My computer was a victim of the Microsoft incident last night. So I have the blue screen and can't log in. So I'm calling in from my phone. So I'm awkwardly asking for next slide every time. So
we appreciate you persevering, Justin, despite the blue screen.
Yes. Yes. So let's see. So I'll jumping in. Just if you're not familiar, Southern Company. This is the overview slide. So nationwide company, but really the areas of interest are there on the left of our electric service territory of Alabama Power, Georgia Power, Mississippi Power, and within those we so we do also have a gas company. As of I always say it's recent, but it's probably been almost 10 years ago now, as a company went out and purchased a gas company that became Southern Company Gas, and that's highlighted in blue. But my role is within the Southern Company Research and Development Team, energy end use, which is now storage and energy end use technologies, and how do you take products that are out on the market, how do you integrate those into Southern Company, and then how do you value them, and how do you make them operationally beneficial. So that's my role, and I'm within the Southern Company Services, which is the term for more of a shared service. I'm within that organization, so I'll work with Alabama Power, Georgia Power, and Mississippi Power, and the gas company sometimes. But my focus is almost exclusively on the electric side. So you can go ahead and go to the next slide. And so this one, looking at it from so Southern Company focus in the Southeast U.S. So it gets hot here in the summer. It's hot today. It's been hot. It's been an even hotter summer than normal this year, I believe. So it's when you think of that, and when you think of our geographic location, you think of hot summers and not necessarily cold winters. But while that's still true, our system has become and is becoming, and I guess continuing to become, more winter peaking. So it's the heat pump penetration is fairly high, I guess, relative to the rest of the country. And our marketing teams over the last 3 decades really have been doing a good job of getting heat pump penetration into the market. And so that has its positives, but it also I guess the negative side of that is on January mornings when it's 15 degrees outside and everybody's heat pump is switching over to strip heat, it causes our system to peak out in the wintertime. So thinking of it through those thoughts of, we have summer needs of reliability, but almost all of our reliability needs are focused in the wintertime. Next slide, please. And so to address that, we are now, and I guess have been for a while, through all of these pilots, looking at different ways of how do you address that winter peak, and to a certain extent the summer peak as well still, and how do you do that both actively and passively. These I stole the graphs from, I think it's NREL's report or maybe just DOE's report, of the energy efficiency side being the passive approach of, if you're going in and you're replacing an electric resistance water heater with a heat pump, what is the differing load shape, and how does that just, there's no integration, no touch point, nothing beyond just pure technology swaps. How does that look to our system? And the green is meant to highlight the positives of it, and the red being the more negative side. So it's, I guess, not such a secret around our business model and how things work. So just the thinking through how these benefit not only the utility but the customer. And so the passive side, just more pure energy efficiency, tends to benefit the homeowners or the customers, because you're using less kilowatt hours and your bill becomes less. So that's good for us, as long as it hits the certain times and the certain windows in the day when those kilowatt hour cells are expensive, or it can reduce the capacity needs and all those different types of things. So there is benefit, but they really have to align before a large program can be rolled out based on one of those. So basically your offset of revenue and sales needs to be offset by your reduction in that peak, in the winter peak reliability issues. They kind of go hand in hand. So as long as the value and the benefits outweigh the lost energy sales, then that's a program we would pursue. And then looking at it from a more active approach of just thinking of it more like a traditional demand response program, and how you can take that new technology or even the old technology and make it respond to grid needs for a few hours a year, several hours a year, or even in the instance of heat pump water heaters. And what we tried to prove out and try to look into deeper was, if you can get away from just a 2 hours a year, 4 hours a year, 4 hours a decade type program, to where it's really just pure capacity and you never call it, into something where you can roll out a program, you can have it be responsive, but you can also do that 8760 a year. So you're becoming more intelligent in your controls, and you're preheating the water heater and different things like that. So how do you balance those two things out and make it more of a more useful demand response program? And so two last things to point out here around a recurring theme that'll be throughout the presentation is reliability of communication pathways, and how we've been working on that for a while. The industry has been working on that for a long time, and I imagine pretty much everybody on this call has been working on that issue for a while. And just our results and our issues, our drop-off rate, if you will, of Wi-Fi communications for the purpose of demand response, and you're reliant on that if you're going the active approach. And I'll show some numbers and some examples of what we have seen in the field. And then lastly, the common issue around all of this, and before the call started, Jeff was mentioning something similar to this, but around you're relying on installers and technicians that are out that may or may not be familiar with the technology and getting that installed properly, commissioned properly, and set up properly to operate longer term. And so you're relying on that as a utility. You're relying on that level to do a good job and to do it properly, which is less of an issue since a heat pump water heater is more self-contained, but it really shows itself on things like HVAC and more complicated low temp heat pumps and those types of things. So just thinking through the whole process and how that comes back and impacts what we look into. So next slide, please. So when I talked about the benefits back to Southern Company and our operating companies of how you use water heaters and getting away from just the couple hours a year demand response and moving that into something that is more 8760, much more frequently used, but balancing that with not impacting anybody's ability to have a hot shower or having warm water when they want it. So making sure those two things can play together. But the projects specifically are highlighted that I'll talk about are in the blue boxes, but thinking through just all the possibilities of what heat pump water heaters can do, or maybe just water heaters in general, of what they can do for grid services and how that connectivity can open up these types of services around capacity being the more traditional demand response. And that's in my cheesy graphic here of capacity is the biggest bucket. It's going to be the biggest bucket probably for a really long time, if not forever. That's where the most dollar value is. And then there's other things you can do in addition to that of energy arbitrage and daily load shifting and moving things on peak and off peak. And then flexibility, taking that one step further and receiving a signal of, for example, the solar production in South Georgia, can you control a fleet of heat pump water heaters to go the opposite of when the solar's really overproducing? Can you dump energy into heat pump water heaters and those types of things? And so next slide. But the projects I'll talk about are all leading up to those three that were highlighted. And so this one is just to maybe date myself and show how long I've been working in this area. But my first project within Southern Company's R&D team was an EPRI collaborative on developing and building out CTA 2045. I guess at that point it was CEA 2045 still, but the general takeaway being we've been doing this for a while. I've been within this position 12 and a half years or so. And this project actually started before I did within our organization. So Southern Company has been trying to think of ways to get these connected, get water heaters connected, and focusing at first on the more the state of where technology was in 2012, I guess it was when I started, and so where technology was there and how we could get one appliance and different appliances connected. So that project, I guess it's still ongoing a little bit with EPRI and with different utilities, but you can go to the next slide. That CTA 2045 project where we were really involved with EPRI and with many other utilities to develop out the standard and the testing of the standard and those types of things. It really started the conversation internally, so outside of the R&D group, but within Georgia Power, but also Alabama Power, of maybe there is something to this. If we can get connected water heaters, can we do something with it? So, excuse me. So this project here I should remember the years, but it was about 2017 timeframe of working with AutoGrid to do a demand response and of a DRMS approach of aggregating and integrating with the REAM water heater API and bringing in data and allowing us to send signals, so forth. The more is like demand response is just pure load shed in my head, but then the next step is to do some preheating and some modifying the load shape that way. So this project did a little bit of that, and it hit around the preheating in the early winter mornings and then letting the tank ride through those events. And we went in and ultimately just ripped out 100 perfectly working water heaters and replaced it with 70 heat pump water heaters. You can see there the different sizes, and then 30 of the new Wi-Fi connected, the new at the time Wi-Fi connected rainwater heaters that are electric resistance. And because some of the takeaways were capacity. So I've mentioned the slide before where capacity is the largest value back to us and will most likely be that way for a long time. Thinking of it from a pure aggregated response, it's about 250 watts of capacity that we get for a heat pump water heater. That number jumps up to, I want to say it's 500 watts. It's on the next slide. I'll get to it later. But it gets double, but still when you're doubling the watts range, it's not a lot of capacity that comes back to us for a traditional demand response event. And so there was a lot of work that went into upfront on getting these water heaters in the field, getting them connected, and then connected back to the DRMS platform. And so all of those things led to very low wattage response rate for us in the utility mindset. So I didn't mention it before, but Southern Company is about 40,000 megawatts of generating capacity. So when you're talking about 40,000 megawatts or even a few megawatts, doing that at 200 watts or 250 watts at a time is it takes a lot of water heaters to make any meaningful impact. And so all that being said, one last takeaway on this one being, or two last takeaways. So we have a lot of thermostat demand response events, and there's high opt-out rates, and that's the opposite of what we've seen in this project and all the other ones that we worked with too. Is it's kind of out of sight, out of mind. It's in the garage. You don't know an event's really happening, even if you get notified that it's going to happen, and unless you go try to take a shower or use hot water and the water's cold, you never knew an event happened. And so the opt-out rate was basically zero of the entire program. So it's a balance between that 250 to 500 watts of capacity value that you get, but you can do that without impacting any what am I trying to say? Any customer, any homeowner. So you can do it behind the scenes with no impact to them. So next slide. And while you're changing slide, let's see the Wi-Fi issue there that I forgot to point out of. I believe at the end of the project, it was about half of the water heaters had dropped offline, and that was a 1-year pilot program. And we went on site and had Southern Company or Georgia Power people within their houses to connect their water heater to the internet, and over time things just dropped off. And it goes it's kind of the downside of that out of sight, out of mind thing that we've seen. Of you can get demand response events, you can get the demand response value without impacting their day-to-day lives, but it's also out of sight, out of mind enough to where if their water heater goes offline, there's not a lot of incentive, or there's not a big push for them to go reconnect it. And so this slide just gives a little bit more detail on the results that we actually had from the program. And on the left is just breaking it down between heat pump water heaters and electric resistance. So it's about double. The part on the left of the graph, sorry, I'll zoom in. Sorry, you had to see it up close with my face, but so I can see the slide. On the left, the preheating of the water heater used this much additional energy, and then when we actually had the event, that the up is the load reduction, so it's kind of reversed what you would think. But then on the far right is the rebound effect and how much the units or the heat pump water heaters or the water heaters came back on at the end, and how much that rebound effect actually was. And then that's broken down on the right by different, I guess there's 1, 2, 3, 4, 5 different days of testing that we plotted here, and those are the results by day. So you can go ahead and go to the next slide.
Awesome,
please.
and yeah, I love these charts, Justin.
I can't take credit for making them. Let's see. Yeah, this is not where I remembered it being, so I'm jumping around in my head, but this one really highlights around the Wi-Fi connectivity issues that we had, and I'll get to it later, but the Georgia Power Smart Neighborhood, this number's a little misleading because it includes more devices than just water heater, but in our first pilot that I just talked about half of the units were disconnected, roughly half after a year. And then in the other project, 16 out of 46 homes were fully communicating after about a year. And that's another scenario where we went in and we physically either plugged things into the Cat5 cables or connected things to Wi-Fi and had things just drop off over time. And I do say that it's a misleading, a little bit misleading of the numbers there because to qualify in that 16, the water heater had to be connected, but also the solar and the battery and the 4 thermostats and a energy metering equipment. So I don't know the breakdown of which is which, but the general takeaway here being that we've seen a lot of issues and a lot of connectivity issues with Wi-Fi and relying on residential Wi-Fi and customer Wi-Fi to ensure the connectivity of these things, and that's just the point of the slide. So, next slide, please. So for this one, the Alabama Power heat pump water heater load shift. So, all right, the smart neighborhoods. So that was, I guess I'll jump back to explaining a little bit of where these numbers came from and the Georgia Power project came from. So there's 2 initiatives that are, I guess, officially wrapped up now within Southern Company, but looking at the how you have a community of grid interactive efficient buildings and how the devices that work or that are within those houses can work together to provide grid services without impacting consumer preferences, connectivity, comfort, convenience, and connectivity. Making sure all those things are still, the boxes are checked, so you're still delivering hot water when you need to, and the temperature in the space is what you need it to be, so you're not making people uncomfortable, and all those things work together. Paired with 2 different models. So Alabama here, you can see the results of the heat pump water heater, but they also had a community scale solar and battery that was about a mile down the road, electrically directly connected into the neighborhood, and where these heat pump water heaters were trying to coordinate their energy consumption with the solar and the battery output and managing those 2 things together in both a grid connected, and when the grid falls off, or drops off, it would automatically isolate the neighborhood, and the solar and the battery and a generator would back up the neighborhood. So these are just some results of when you had a more 8760, but even down on this project, we worked with Oak Ridge National Laboratory to develop out some transactive controls, or it's just a home energy management type system to where you're taking in a signal from the grid and then managing kind of a model predictive control of the devices themselves.
Yeah, that's crazy.
And so having all those things work together, this is the result of what we did with the heat pump water heater load shift. And so it's a summer load reduction of up to 60%. Winter, it's about 45%. But if you really dig into that, it's 60%. It's the same story as before of low wattage response that it comes back to us as. And so, but it's again, no impact. Nobody noticed it, that it was happening. You can do all these things behind the scenes, still perfectly deliver the hot water when needed. And let's see. Yeah, so it still provides the services that we're looking for, but it does it at a better output. So next slide, please. So this one, jumping from Alabama over to Georgia Power project, to where it's a similar setup, but this one has behind 1 meter or in one house storage, battery storage, rooftop solar, heat pump water heater, and effectively four smart thermostats, but it's 3 Ecobee thermostats and 1 different thermostat on the roof. And Oak Ridge was also involved in this one to develop out the controls, and this just shows some results of how they were taking in an hourly pricing signal and then responding with their controls back to manage the heat pump water heater output. And I should probably also mention the Alabama project used the Rheem heat pump water heater, so they had more controllability of the set points, and this was pre Rheem having CTA 2045 in their water heater, so it was the pure EcoNet platform, and having temperature settings, mode settings, and those types of controllability through that API. And so the results from that one was more, they had more flexibility in how they could control it. In this project, it was the A.O. Smith 66-gallon heat pump water heater, and the connectivity being through that CTA port of having, I guess, less to choose from, maybe ultimately the same functionality, but different ways of controlling it. And so preheating shed or load up shed and those types of event driven responses are here, and shows the results of the winner.
One clarification, Justin. So this was before advanced load up, correct?
Correct. This is the base original CTA 2045 standard.
And since you said you were playing with set point temperatures, did load up only bring the temperature to 120 degrees, or were you able to go above that with either the API or the load up?
For the API, yes, we could. For the load up, no, it was limited.
Understood. Thank you so much.
Yeah, and I guess another clarifying point I should have mentioned is that in all 3 of these projects, we have had mixing valves. So since we did a fresh install, we were able to put mixing valves on the outside of the tank. So we had the ability to go above 120 if possible at least in the Rheem situations where we had that capability to control the temperature, and we could go to 140 and set the mode as well. But they had the mixing valve there to prevent any type of scalding issues.
Yeah, that's an excellent clarification.
Let's see, next slide, please. And this is just the same type of results, but looking at it from the summer instead of the winter. So the hotter outside, these are, I guess, all of them have been located in the garage. And so the hotter incoming temperature in the summer leads to, but still getting, let's see, 15% load reduction. Next slide, please. And then this one, so the first 3 talked about the more active approach of kind of demand response, the more involved demand response, to where we had actual controls that were built for the system to look at forecasted prices, forecasted usage, forecasted temperatures, all those things taken into account, and trying to develop out a more optimal, it's a little bit overused of a word, but a more optimal schedule of how the water heaters operated. And this is from just the passive side of the pure heat pump water heater technologies. And there's nothing really to compare it to on here, but the different seasons and the load shapes of the water heaters that were in the neighborhood. So no controls, just running as if they are normally installed. You can see so Alabama was 62 single family homes, and that one was less than 20 kW of total energy consumption on average for us at its peak in the wintertime.
Thanks, Justin. And this was these did have a backup resistance element, right?
Yes, correct.
Cool. Okay, so relatively low average load despite that.
Correct. And they were 80-gallon heat pumps or heat pump water heaters, so they had some additional storage capacity built into it. So for code, I think 66 gallon, maybe even 50 gallon would have been fine for these homes, but we were looking at it from almost an overbuild perspective on everything of what does it look like if you can get the most storage capacity in a water heater. How much thermal storage does that give you, and how much flexibility does that enable you to get? So that had the other benefit of the heat pump was able to create more hot water and not have to run the resistance heat quite as much. Next slide, please. This is a similar takeaway from the Georgia Power project, where on the left hand side you can see the I think it's 5-minute average data. It might even be 1-minute data from all of the water heaters in the neighborhood, and that compared to what a typical electric resistance water heater would look like on the load shape in the green. And it's, if you aggregate it up to the whole neighborhood, it's very much under the typical demand for that week. But if you look at it from the right hand side, that the averaged out values, which I guess is ultimately what matters to us, because we're talking in megawatt scales, and these are in watts to kilowatt scales. The aggregate value is all that matters, but that aggregate is made up of homeowners that have different schedules, different operating conditions, and even different settings on the water heater itself that they program that we had nothing to do with. And so you can see the differences in load shapes between 4 different houses in the neighborhood, and how one looks like their heat pump plus backup resistance turned on for about 2 or 3 days and just ran constantly. They don't have a good reason for why that happened, other than it looks like it did. As you have a more typical one on the right, where the heat pump and the electric resistance was able to come on, meet the demand, and turn back off. And then the 2 on the bottom, where the electric resistance rarely, I guess if ever, had to come on to meet the demand, so the heat pump could just run and keep up with everything. So the general takeaway there being, I'm not telling you anything you don't know, but that the customer preferences and how they operate the system can impact what it individually it looks like in their house, but then if you smooth it out and average it out, and what it becomes back to us is something that's still more beneficial, or still less kW back to us than a traditional electric resistance water heater. Let's see, next slide, please. So this is what I meant to put at the beginning of those slides, of the takeaway of, or the background on the smart neighborhood initiatives. Already went through this, but the one on the right being the Alabama Power Smart Neighborhood, where you had the community scale microgrid with, it says on there that I think it's 330 kW of solar. There's a battery backup system, and a natural gas generator that can power those 62 homes in the bottom left box. And they had some connectivity between both the HVAC, variable capacity heat pump, and the heat pump water heater were managed within those houses by the controls to balance out production and usage inside of the house. And then on the left being taking a similar model of the microgrid assets and bringing them behind individual meters, and having each townhome in Atlanta having 3.5 kW of solar, 20 kilowatt hours of storage, and then they connected heat pump water heater and connected thermostats, and how those 2 things differ and how they get managed together, and how you can take a water heater and put it into more of a home energy management type setup, to where it's one piece of the house energy consumption, and how it can cooperate with the thermostats, excuse me, with the HVAC and the thermostats, and how that can work with the rooftop solar, and how all those things can fit together to provide every service that's needed on the homeowner side, but also doing that at a more beneficial to Southern Company load shape back to us. Next slide, please. So this one is just looking at it from a pure, almost maybe even too high of a level, but plotting how often the aggregate load is at different wattages. So the flatter the curve being, or the steeper the curve being, it's more peaky. So there are more times where it's, so let's see if I can explain this better. Sorry. So on the left-hand side being, it's at its highest wattage for, I guess that's maybe the lowest wattage, but anyways, the plot is to say if it is flatter, then that means it is just a continuous flatter runtime as well. And so it is not a true candidate for more traditional demand response, because turning it off does interrupt the process where you have a peakier system of the HVAC is the one on the left. But if you can clip those few hours of a year that are really peaky, then that fits into the more traditional demand response bucket, and it has more value there because you can hit it in short periods of time over the year. Whereas if the flatter it gets, the less it fits into a more traditional model, because it's not on and off. It's more just a continuous runtime. So
you explained that
slide,
well.
please.
Yeah, so it looks like EVs, for example, are very not peaky, like they're just on rarely.
Yes, and there are, I believe, 16, it's 10, 12, 14, somewhere in there of homes had an EV out of the 46 where this data came from. So that also skews it a little bit down further just because of the penetration of EVs, which 16 out of 46 in Atlanta is really high. And that if you went to another neighborhood, it would most likely not be 16 out of 50 homes that have an EV.
Got it. That's great context.
Go ahead and go to the next slide, please. Well, I'll try to get moving here. I think this actually might even wrap me up, but I guess all of those projects led to where we are today, which is we did a lot of pilots. There's even a pilot that I didn't mention that I wasn't involved in, but the add-on controls for, I guess it's mostly just electric resistance water heating, but looking at it from as many different angles as we could of residential water heater demand response. And all of that has, at least to today, been a bunch of pilots and no programs. So I think I hit on the main cause of that being the amount of cost to enable demand response on water heaters, paired with the relative low wattage that is received from a demand response event, and then the price of capacity on our end. So all those things put together, there have been more technically economic ways of getting capacity for us throughout, I guess, over the last several years. I will say that's a somewhat narrow view, because I at least tried to point it out or mention it before of we value things on capacity, and that's the 250 watts that you get from a demand response event. But there's much more value that you can get out of a grid connected water heater than just capacity. And those are things that were, at least as of today, most utilities overlook. And so there's a little bit taken into account, but ultimately the breadth of things that you can do with a water heater, because again, it's more of the out of sight, out of mind in the homeowner's perspective. And as long as they're receiving hot water, it doesn't matter. And as long as you can get all those things stacked up together, then I do still think there's a use case for rolling out heat pump water heater connectivity programs, even in the Southeast. But we're working on how to actually value those services back to us beyond just broad round numbers, $100 a kW times 250 watts per year. I guess that's $25 a year of value to us. And how do you share that with an incentive back to the participant? And so cut it in half, you're down to $12 of value a year. So the cost and benefit, getting those numbers to work out hasn't historically been easy because of that, because of the value side of it. And so there's different ways that the value can go up, and $100 is kind of just made up, but it's ballpark roughly close. And but that if that number becomes $1,000 or something, then these become much more valuable and much more likely to get rolled out. Or if you can take $100 plus $50 plus $25 on top of that by getting more value streams out of it, then it becomes a different story. And then, so to wrap up, I think what's next at Southern Company for heat pump water heaters, it's it's kind of the active versus passive again. Does it need to become a point where, especially in our climate, where do you need to have that active touch into water heaters, or can we take the 120 volt heat pump water heaters that are now on the market and, at least in most areas of our geography, have those installed? The capacity now goes to 1.5 kW from a maximum of 5 before, down to 1.5 kW. And is that good enough? And we go that route instead of having the passive, or to go in the passive route instead of having the active route. And that, I think that's at least a question that we're trying to run down and see what the different values are of that, and what the benefits and the pros and cons of that approach would be. Let's see, I think that's it for me. Next slide, please, just to make sure. There's more. That one's not that relevant. We can skip that slide. All right, I'm going to say that's it for me.
Awesome. Well, thank you so much, Justin. Really, really appreciate it. That was a fascinating presentation, and I certainly have a bunch of questions, but let's let other folks go first. And slide 23, Jeff, looks like you had a question. Let me go back there. What is the saturation of electric water heaters in Alabama? So basically, is it more of electric or more of a gas market there?
I know the answer for heat pumps, and I'm going to just make the assumption that it's pretty close. If you have a heat pump, you most likely have an electric water heater, and that it's about 50-50. Atlanta is less, it's more gas, less electric, but South Alabama is much higher than 50% electric. So but on average, within about 50-50.
Great, thanks. Yeah, one of the numbers I've heard in the Southeast, it's more like 65%. So you may not have to use the product you show there, which is a 120 volt. A lot of them are direct swap outs with a 240. Right.
Yes.
Yeah. Thanks.
One question I had real quick was, I noticed, you had a bunch of water heaters in your fleet. I think you had like 70 for one of the pilots, you said. Did you design custom controls for each of the water heaters, or were they all receiving the same signals? How did you go about that for the different load shapes?
For the original pilot that had 70 heat pump water heaters and 30 electric resistance, and we worked with Ream and AutoGrid. So the first one I talked about, that one was pure, everybody got the same signal, everybody at the same time in the morning got a preheat, and then at the same time they got the end preheat, and then they all had the same exact signal. So it all was just a simplified blast of demand response. The other two pilots where we worked with DOE ultimately to develop out the controls, those had individualized per house, even per device, a model built out that would manage its own consumption based on that home's, how they use energy and their preferences.
Amazing. And were you able to just kind of plug that into an algorithm to get the signals that should be optimized? Because I know it can take a long time to develop bespoke controls for each household.
Yes. No is the answer. It took a long time and a lot of effort and a lot of IT problems that we had to overcome. And one thing doesn't get talked about enough is the data flow and API connections and difficulties with getting APIs from vendors, and every vendor that that we talked to, and the legal that has to get involved, and the cost of data, and all those different things coming together. And that's a long answer to your question, but ultimately, no, it was not easy. But we did eventually build everything out.
Awesome. No, that's a great answer. Thank you. It looks like Scott has a question as well.
Yeah, thanks, Noah. I was just curious because you've been mentioning the data issues with APIs and internet connectivity. And my impression is that kind of one of the big advantages of using an open standard like EcoPort CTA 24/5 is that you don't need the API. So I guess I was wondering, like, because would that alleviate a lot of the connectivity issues that you had if you were using that open standard, and you could send the signal through FM radio or the internet, or it opens up just more methods.
Yes, absolutely. And I think I sell it a little short in Georgia because in that project, we had the A.O. Smith heat pump water heater with the Skycentrics controls through CTA 2045. This was also 2016, 2017, so it was many years ago. But even at that time, there was the ability for local control through that platform that would have solved a lot of the communications issues. But because Ecobee is Wi-Fi API thermostat based, and let's see, we had Delta Electronics for the solar and the battery. Those are all cloud-based API, and there were several other vendors that were all cloud-based APIs. So we drug the heat pump water heater into that same architecture because everybody else in the house that we had to communicate with was already in that, doing it that way. So we were already having to do that for everybody. So we didn't have to have an additional piece of hardware in everybody's home that would fix those problems. So I think that answers your question, but I think the ultimate answer is yes, it should. At that time, and I will confess I'm out of date on my EcoPort knowledge, and I'm a few years behind on what the developments are there. But at that time, there wasn't a good alternative to Wi-Fi that fit our specific use cases and needs.
Yeah, that makes sense. Tristan, do you want to chime in there?
Yeah. Hi, Justin. Good to see
Copeland.
you. So I think you described the transactive energy where you kind of had a gateway that was playing with multiple loads. At that point, was that connecting locally to all the loads, some of the loads, none of the loads?
It was all some of the loads, I guess, all the main loads, and the gateway was in the cloud, so it's like a virtual gateway, I guess. Everything was sitting out in, I guess, our cloud till we've reached into everybody else's API cloud, brought data back to us, and then sent signals out and managed through that approach. And from that, it connected to the main things you would think of: the water heater. We tried to get an EV charger. That's another example of APIs not working out. We wanted to have visibility into the EV charger, but couldn't get access to the vendor's API. We had solar and battery thermostats, several thermostats, and I want to say there was one other. The general things you would think of when it's the large loads within a house. We had visibility and controllability to some extent of all of those.
Cool. And just as a quick update, I mean, not only from Skycentrics, but from others, there's now cellular modules, Wi-Fi, and even Ethernet wired modules to kind of break down the wireless and just have a solid wired connection. So it has come along.
Good.
Tristan, would
That's
you
good to
mind
hear.
touching on in what situation you would pick a different one? Because I think it can be hard to know in what kind of pilot or program you want Wi-Fi versus cellular versus radio versus something else.
Sure. It looks like Jeff has his hand up, and he can certainly
Oh,
talk
yeah.
about cellular perhaps, but the wired modules are really cool for multifamily. We had issues going into multifamily where there's like every apartment has Wi-Fi, so you definitely don't want to be adding to that mess. Inexpensive wired modules that go back to our gateway. We can put 25 water heaters on one little gateway, and that's seemingly really sexy for multifamily. Jeff, did you want to talk about cellular?
Yeah, so I think cellular has its own merits and its own challenges, as does FM radio. But I think there's also some movement afoot under AMI connectivity to AMI meters. So, but the challenge with AMI meters is there's, I don't know, 40 or 50 different platforms and 40 or 50 different ways of doing it. So I think the cellular radio and potentially hardwire is by far and away the way to go. We've seen study after study, and Justin, I think you reaffirmed this with this, that Wi-Fi is not a solution. It's not viable long term. It's great for a short-term pilot, but if we don't have reliability and or utility is using these resources as a peaker plant, which is what they're going to do, they need to be 5 nines reliable, and a Wi-Fi connection is not that. So.
It's a great answer, Jeff. Christopher, do you want to chime in too?
Yeah, I do. Chris Freeman, Remanufacturing. A question I have is as we've been talking about different communication protocols and CTA and other stuff, JA13, all these other things, as we talk about the interconnectivity, do we as an organization have a stance or a viewpoint on the cost push down and effect to the end customer? Now we're talking about additional infrastructure costs on, yes, they're buying water heaters. How do we pay for the cellular? Who pays for that? We need to come together with a recommendation on how we make this happen. I think that's a big downfall or a missed opportunity from what was done with CTA in Washington and Oregon. We talked about implementing the connector, which is great, but we didn't put the car in the garage and talk about what's the end-to-end support and how do you make sure we can actually deliver the full solution, because that's a partial solution and the economies of scale have not been talked about.
Do you want me to address that? So all the heaters coming into, all electric heaters over 40 gallons in Oregon, Washington now require CTA, an active connectable CTA 2045 port. The next step is to connect them. And I would say NEA and other utilities here in the Northwest are working on that, and we've got some great intervention strategies. That cost of that connectivity is borne not by the customer, not by the OEM, other than providing a Molex connector and the required software to connect. A one-time fee, by the way, and you know that, Christopher. But the other, that's all borne by the utility and or the grid services that need to access that. So that's not borne by the individual. That's the utility's cost. It is expensive, but I would say maintaining other systems that have a 44% drop off within 1 year is a very expensive process of keeping them connected.
Well, I'm going to wrap up things there. Jeff, thank you so much. I think we could probably get way deeper into this too.
Yeah.
So I think we may even, want to come back to this next time, talk about, save some of these chats. But I'm glad that, everybody's eager to jump in. This is great. And it's really awesome to have, more people vocalizing in the chat and coming, on camera and all that too. So that's wonderful. I just wanted to say a big thanks to Justin for such an excellent presentation. That was awesome to learn what Southern Company has been up to. And I did just have a small announcement. Next meeting will be August 16th. We're on our 4-week cycle. I'll send that meeting invite out shortly. And if you want to present, I think there are a lot of folks on here who have a lot of knowledge and have not spoken on this call before. Definitely shoot me an email and we can touch base. I would love to have you present. So thank you all. Really appreciate it. And the recording will be on YouTube in probably early next week. And yeah, have a great one, everybody.
Thanks. Stay cool out there.
Thanks, everyone.
Thanks for having me.